So now that we've talked about the various classes that make up the server side of this PrimeCheck application, let's go ahead and take a look at the client side. So here you can see the client code. This is something called PrimeCheck Client, and it's something that's known as a component. It's an annotation that's known as a component. You'll see why we annotate it later. And this client uses Spring MVC features to perform remote method invocations on the PrimeCheckController web service. So the web service is running in a server that's basically managed by the PrimeCheckController, and this is how the client is going to pass requests to it. And once again, when we look at the code, keep in mind how very little code here really discloses much about the fact we're doing web programming, and most of it looks pretty much like we're doing Java programming, with a few very carefully abstracted exceptions to what I'm about to say. We're going to get ourselves the base URL for the server, and this is what the server's base URL is. Just to make this example simple, it runs with localhost as the IP host name, the host name for this, which is just the same machine that I'm running the client on. Of course, a production server would run in another non-localhost server name, and it's going to be contacted at port 8081. And we knew that because of what we looked at when we took a look at the server application properties. We are listening on port 8081. So that's basically how we get the server base URL. In this case, this is meant exclusively just for testing purposes. And when I run the program here in a second, you'll see how that all works. It's very straightforward. Okay, popping back over here for a moment. Here is a field called mREST_template, which is once again an auto-wired field. And that basically connects the PrimeCheck client, which is this class, to the REST template. And we'll see momentarily that the REST template is a feature that comes out of the box with Spring that allows you to perform HTTP requests synchronously. Now, there's a bunch of different clients you get with Spring. This is the one that's kind of the classic one that's used for synchronous programming with WebMVC. There's another one we'll talk about later, not today, but in another context, called Web Client. And that's intended for use with asynchronous programming with something called WebFlux. So we'll talk about that when the time is right. Right now, we're just focusing on synchronous communication. And they all, each of these techniques has its pros and cons. Here are the methods that we've got. One is called test individual calls, and another one is called test list call. And you'll see why it's named, those methods are named those things. These methods are going to be called by the test driver, which we'll look at later. So test individual calls takes in a list of integers, which are our prime candidates, and we can decide how many there'll be. We can also give a range of how large we want them to be, but assume for sake of argument, it's a list of randomly generated large integers. And we take in a Boolean flag that indicates whether or not we want things to run in parallel. And now we're going to go ahead and test individual calls. So what that means is we're going to make one call at a time, as opposed to passing the entire list in one fell swoop. So we take our prime candidates list of prime candidates and we turn it into a stream. We then conditionally enable streams to be parallel stream or not. By default, by default, a stream is a sequential stream, as you know. If we don't want that, we pass in a Boolean that's true, and that turns this into a parallel stream. Very good technique to be aware of. And then we actually do the work, and this is pretty cool. So we use the stream together with the map transforming operation. It's an intermediate operation that transforms. And what we say here is for each prime candidate in that stream of prime candidates, we're going to use this webutils helper method that I wrote, which we'll look at in a second, called make_get_request. And based on the name, you might surmise correctly that make_get_request is going to create a URL that will include that base URL, the host name and port number that the server is listening on. It'll take the prime candidate, which is an integer, and it will encode it in a way that can be passed as a string as part of the URL. And then it's going to make a request to the underlying server using HTTP as a way to encode that request. And so make request will do exactly that. We'll take a look at that code in a second. Before we look at the code, though, what we get back will be the result from making that remote method invocation on the server. So we'll give it a prime candidate, we'll get back a result. And then we're going to collect all those results up into a list using good old collect. So we have a list of integer results. And then we're going to display the results, passing in the original list of prime candidates and the list of results. And we expect there to be a one-to-one mapping for each item I in prime candidates. There will be a result in results sub I that's the matching result. So we can go ahead and display them. So let's take a look at make request. It's a very interesting little helper method, and it's defined in this helper class I call it web utils. Here's what make request does. You can see it's a generic method. It's a generic static method that makes an HTTP GET call to the server. And we'll talk about how we get the server set up in a second. And it passes in the URL that's passed as a string, and it returns the results of type T. And you'll see how that works as well. So one parameter that's passed in here is the REST template. That's how we know how to make calls. That's how Spring will let us make synchronous calls on a server. We pass in the URL. We'll see how we construct the URL in a second. And then we pass in the class, which is what we want the result type to be. And so we use the REST template parameter. We call a method that's defined on a REST template called getForEntity. And we pass the URL. And we pass, and the URL is where we're going to make the connection. What server, host name, what server port number, what particular method we're calling, what parameters we're passing, all that stuff is encoded as part of the URL. And then we also indicate how we want the result to be treated. What type do we want it to be? In this case, it happens to be an integer. And what comes back here will be basically a request or a response entity, and then we get the body of the response entity, and we treat it as an element of type T, which is, of course, matching whatever we passed in here. So it'll be basically the integer class in our case. So if you go back and look at how we call this method, you can see we pass in integer class as the type of the result. We pass in the REST template that we initialized using the auto-wired field up here. There's the REST template that was auto-wired. And then down here, we make a helper method call called make check if prime URL. So we're going to go look at that now. And notice how we pass in the prime candidate. So the prime candidate is that each of the elements that's in that prime candidate's stream. So here's make check if prime URL. It takes in an integer. It takes the base URL. Remember what the base URL was? It was the server base URL, which is the host name and the port number. It adds in the check if prime method, which as you can see was /check if prime. That's what corresponds to the get mapping that was defined over here. So you can see that that was the get mapping that we defined over there. That's what we're passing it to. We then pass in essentially a kind of a query parameter that says the prime candidate is going to equal whatever integer we're passing in. And in fact, if you take a look at prime candidate and you look at the PrimeCheckController, you'll see that that's the name of the parameter. So the parameter's name is prime candidate. And so this is basically just saying, well, the name is prime candidate. So here's the name of the method, and this is the value. And underneath the hood, Spring will create, or we're going to create a URL that corresponds to the get request that will then be passed to the make get request method, which will then take that URL and pass it to as the URL to the getForEntity call on the REST template. And that will be what's used to send the request to the server. And then the Spring MVC code on the server side will then unpack that request, go look up in its tables, find the appropriate controller, find the appropriate endpoint handler method, strip things out, put them into a native Java call format by using reflection, and then invoke that method call to call the server method. Once again, all that stuff is hidden from you mercifully. You don't have to worry about that. So that's basically what's happening for test individual calls. Let's go down and take a look at what happens with test list call. So test list call is going to take a list of prime candidates, list of integers, and a Boolean, which will be true or false if we're doing parallel streams. And you can see that in this case, we're going to start out by making the check if prime list URL. And this is a little bit more complicated. So what we're going to do here is we're going to use a helper method defined in our web utils class called list to string. So we take the list of integers and we call list to string. And we do a very clever technique to convert this list of integers into something that can be passed as a query parameter to a URL in order to have the receiving side, the server, treat it as a list. And here's how we do it. It's super cool with Java streams. We take the list of integers, turn them into a stream of integers, map each element into a string. So now we basically have a stream of strings that correspond to the string encoding of the list of integers. So we have a list of strings, which are the encodings of those integers into strings. And then we collect those things up into a single string that joins every element in the stream using a comma as the delimiter. So basically what we're doing is we're creating a single string that has a bunch of string representations of integers with commas separating them. So we have a comma separated string, which is how you can pass list parameters, or one way you can pass list parameters using URLs in HTTP. So this is just a conversion operation. It's a great thing to have as a utility because you don't want to have to write this over and over again. Notice how easy it is to do that with Java streams, really simple. So we create this list, and then we encode that list and the parallel parameter using this factor method called MakeCheckIfPrimeListURL, which is similar to the MakeCheckIfPrimeURL method we called before, except this time we're going to encode it as a list. So we have the base URL, which again, if you recall, is just the host name and port number the server's listening on. We have the checkIfPrimeList, which is the part of the URL that's going to designate the method we want called, the endpoint handler, if you will. And then we say prime candidates will be the list of integers. And if you go look at the PrimeCheckController, you'll see that down here, prime candidates with an S is the name, and it's a list of integers. And then we're going to say, and parallel equal, and then the value of that parallel parameter, which could be true or false. So that's what's going to indicate whether we want this to be parallel streams or not. So that's how we're going to make ourselves the URL. We're going to encode the URL for making this kind of a call. And then down here, we're going to use a slightly different type of method call on make request template. So this time we're going to use something called exchange. And what it does is it takes that URL, it packages it up and sends it as a GET request with no request entity. And it wants the return type to be an array of integer objects. So that's what's going to come back here. And so we get this back as a response entity of integers. It's a response entity that's parameterized by an array of integers. That's how GET requests come back in a response body. We then take that response entity, get its body, which of course is that integer array, and then we convert that into a list because we're working with lists, but under the hood, HTTP is sending these things back as arrays with JSON, of course. So we convert that array into a list. So now we have a list of results. We display the results if we're debugging along with the prime candidates. And that is basically what we do when we test this call. So that's basically walking through the client code. And you can see here that there's a little bit of stuff in here that requires some knowledge of what's happening under the hood with respect to HTTP, mostly in terms of building these URLs with the correctly encoded values, either lists or Booleans or whatever, just the values that come in there. But most of this looks pretty much like you're making a good old method call. You know, there's a little bit of HTTP knowledge here and some helper classes to allow you to do that stuff in a convenient way. But by and large, it's pretty clean and pretty concise, which is cool.